A problem based on a moment generating function. Here x is a discrete random variable and the probability mass function of this x, it is given by fx of x, which is equals to 1 by 3 whenever x is equals to 1, and when x is equals to 2 it is equals to 2 by 3. So the first part is find the moment generating function, and the second is using this moment generating function find the expected value of x and the variance of x. So a quick review of the expected value and the variance. Basically, expected value of x, this is nothing but, since it is a case of a discrete random variable, so we'll use summation over all the possible values of x. Here x is equals to 1 and x is equals to 2 only. So expected value of x, the function random variable is x here, so this is x and this is the probability mass function, that is fx of x. And what is expected value of x square? So if it is x square here, so we'll again use summation because it is a case of a discrete random variable, and x square means write x square as it is and the probability mass function of the random variable x, and take the summation over all the possible values of x. We are using summation here because it is a case of a discrete random variable. So from these two we can easily find out the variance of x, and variance of x, this is nothing but the expected value of x square minus expected value of x whole square. Now coming to the first part, what is the moment generating function? By definition of the moment generating function, this is mgf, which is written as mx of t, and this is the expected value of e to the power tx. Here tx is a helper and capital X, this is a random variable. We have to find out the moment generating function of this capital X, that is this random variable. Now, by definition of expected value, the function here is e to the power tx. So, since x is a discrete random variable, we'll use summation here. And the function here is e to the power tx. Write this function as it is, that is e to the power tx. Now, the probability mass function of this eh, random variable fx of x, and summation over all the possible values of x. So here we have two values of x. One is x is equals to 1 and the other is x is equals to 2. So when x is equals to 1, it is equals to 1 by 3. So basically when x is equals to 1, this is equals to, so when we plug in x is equals to 1, this x is equals to 1. So this becomes et of 1 into fx of 1, that is the probability mass function at x is equals to 1, plus E when x is equals to 2, we have the probability mass function. When we plug in x is equals to 2, that is the probability mass function at x is equals to 2. So at x is equals to 1, fx of 1 is 1 by 3. At x is equals to 2, fx of 2, it is 2 by 3. So substitute fx of 1 and fx of 2. So this becomes e to the power t, because 1 into 2 is t, and fx of 1, this is 1 by 3, plus e2t, and fx of t 2, this is equals to 2 by 3. So the moment generating function, this is given by 1 by 3 e to the power t plus 2 by 3 e to the power 2t. So this is the moment generating function, and this is defined for all the real values of t. So that means this is defined for all t belongs to real number. Now second is using moment generating function. Now this is the moment generating function for the random variable x for the given probability mass function. Now for the second part, we have to find out the expected value of x and the variance of x using this moment generating function. So expected value of x, this is given by, if we are finding out expected value of x, that means differentiate moment generating function one time, that is mx of t, and then plug in t is equals to 0. If we need to find out expected value of x square, then differentiate moment generating function two times and then plug in t is equals to 0. So first we compute the expected value of x. So here the moment generating function is 1 by 3 to the power t plus 2 by 3 to the power 2t. So for expected value of x, simply differentiate moment generating function one time and then plug in t is equals to 0. So expected value of x, this is equals to differentiation of the moment generating function one time, which is 1 by 3 e to the power t plus 2 by 3 e to the power 2t. And once you differentiate with respect to t, then plug in t is equals to 0. So that means the differentiation of this first term with respect to t, it is 1 by 3 e to the power t plus differentiation of the second term with respect to t, it is 2 by 3 e to the power 2t, and this multiply by 2. So that means, and then plug in t is equals to 0. So this is equals to, when we substitute t is equals to 0 here, so e to the power 0 is 1, which is equals to 1 by 3 only, plus 2 by 3. When we substitute t is equals to 0, so it is e to the power 0, it is 1, and 1 multiplied by 2 is 2, and this 2 multiplied by 2 is 4. So this is 4 by 3, and finally expected value of x, this is equals to 5 by 3. So this is the value of the expected value of x. Similarly, we can find out the expected value of x square. For expected value of x square, we have to differentiate the moment generating function two times, that is mx of t, and then plug in t is equals to 0. So one time differentiation of the moment generating function, it is this one. So we use this term as it is. So this is d by dt of the first differentiation of the moment generating function, that is mx of t, and then finally plug in t is equals to 0 here. So the one time differentiation, it is 1 by 3. We are using this value as it is, that is 1 by 3 to the power t plus 4 by 3. This 2 into 2, this is 4 by 3 e to the power 2t. Now again differentiate with respect to t. So this becomes 1 by 3 differentiation of the first term with respect to t, it is 1 by 3 e to the power t plus 4 by 3, that is this is 4 by 3 as it is, e to the power 2t, and this is in multiply by 2, and then plug in t is equals to 0. So when we substitute t is equals to 0 here, so it is 1 by 3 e to the power 0, that is 1 only 1 by 3 plus 4 by 3. So 4 multiply by 2, it is 8. So this is 8 by 3, and e to the power 2 into 0, that is e to the power 0, which is 1. So finally expected value of x square, this is 9 by 3, which is equals to 3. So the variance, this is equals to, as by definition of this, variance of x, this is given by expected value of x square minus expected value of x whole square. So expected value of x square, this is equals to 3, that is this is 3 minus expected value of x square, which is nothing but 5 by 3. So expected value of x, this is 5 by 3 and whole square. So this is 3 minus 5 by 3, that is 25 by 9, which is equals to 2 by 9. So this is the variance of x. Hope you like this video. If you like this video, please don't forget to hit like, share and subscribe my channel. Thank you all. Thank you for watching.